All right, in this module, we're going to start talking about how we start to um, do useful things with the X-ray diffraction data and what that looks like. So uh, the first thing we can do is obviously if we have crystalline phases in a specimen, we want to get the crystal structure and information about that. And so we can do that by comparing two archived diffraction spectrum. So this archived data comes in the form of what we call a powder diffraction file. So you might be able to see that down here. The abbreviation is PDF. I know that can be confusing because there is a portable document format .pdf that a lot of you use for documents. So that's not to be confused with that type of PDF. But this powder diffraction file, or PDF, basically gives you all the information pertaining to an archived X-ray diffraction spectrum. And so this is what it's going to look like here, something like this, a version of this. There's an organization, the ICDD, which is the International Center for Diffraction Data. They actually prepare databases of these PDFs that are updated regularly, and typically you have to pay for these databases. So that's one kind of limitation. Is there are some open sourced databases online, but the most complete ones you typically have to pay for. So this is kind of the example of some of the information that you're going to see in it. So let's just kind of go over what we see. So the first thing that you'll want to look at on this PDF, and probably how you found that PDF, is actually by the PDF number. So that's what's up here, the 740566. This is the PDF number, or PDF card number. So back in the old days, you actually had to go hunt down a physical card that contained all this information. So it'd be, sorry about that. So you actually had to go hunt down cards, much like in the library if you have to use ISBN or title or whatever kind of database searching parameters. So you'd have to search through and find the card that you needed based on the PDF card number. So that's the first thing you want to look out for. Also, it's going to give you information about the phase, so the phase name. So here it gives the chemical formula up top, and then right below it, it gives the chemical name, so calcium hydroxide phosphate. It'll also be beyond that. The better PDF cards will tend to give you some of the experimental conditions. So that were run. So in this case, it tells you the radiation is copper K alpha 1. That gives you the lambda value. It doesn't give you the filter in this case, but a lot of times it'll give you information about that run. Along with that, they tend to include the reference for it. So just like you would reference a journal article, that's given up here. So you can go back to the original paper and find out more of that information if it's lacking. So they'll often give the reference information. Beyond that, it should give you crystal structure information. So it's in the hexagonal system, a primitive lattice. It gives you the space group, which we talked just a touch about. It gives you lattice parameters and angles if needed. So here A and C for hexagonal, it gives you those pieces of information. And then majority of it is actually going to be the peaks. So it gives you the 2 theta values, and that would be for the given radiation source. It might just give you a D spacing. And then it gives you the it gives you the intensity in this case, and then the HKL values. A lot of times it'll give you the relative intensity in those cases. This one doesn't look quite this is in relative intensity, but it's out of 1,000 scale, as opposed to a lot of times it's out of 100. The biggest peak, which is this one, is often 100% peak. In this case, it's looks like it's 1,000 or 999. So that's the main difference there. So it gives you all the peak information. And you can see here there's a lot of peaks for this particular phase. So that's something to consider. Most of ours will not have nearly as many. So this is kind of all the information that these cards would tend to have. So again, like I said, these used to be literal cards. Now it's all computerized. And so the computer search match programs out there will take the information from these to be able to compare your sample to these archived samples to see if it's a good fit and a good match for those specimens. There's other ways to index and determine what phases we have. Computer, like I mentioned, there's computer search match programs out there that use these database PDF cards. There's something called the Hannawalt search volumes, which is kind of a more manual version that you can use using these big volumes that have a lot of the PDF information within them. And there's also more simple versions that allow us to index, for example, cubic structures or hexagonal. And so that's what the next module is going to be on, is to use a simple method in order to index cubic structures specifically. And so that information will be outlined in the quality text I've been referencing, but we'll give you a breakdown of the methodology in the next module.